At the top of the next page, we are going to be factoring, not solving, not taking it all the way down to our solutions, just factoring. Up at the top, I want to go over our types of factoring. First thing we always check for is a GCF. Number 2, I normally check to see if it's a fake or a real quadratic. Fake quadratics go 4-2 constant, real quadratics x squared x constant or 2-1 constant. And then our other types of factoring. Sum and difference of cubes and difference of squares. And why I'm putting these together is all three of these methods will always only have 2 terms. So real and fake quadratics we identify from the powers. Sum and difference of cubes and difference of squares will only have 2 terms. Last type of factoring, grouping. And how I identify grouping is there are 4 terms. So these are our 4 types of factoring that we want to have in our arsenal for attacking these problems. So what I would like you to do is try number 17, number 19, number 20, and number 21. So 17, 19, 20, and 21. I want you to start with those 4 problems. I'm going to give you about 4 minutes to try those, and then we're going to regroup to go over the answers. Go. Number 17 threw a lot of third block off. On this problem, we see that we have 4 terms. We want to do factoring by grouping, but is there something we can do first? There is a GCF, and if you're like, what if I don't catch it in the beginning? You could catch it at the end. If you had x plus 2 and then 2x squared minus 4, the 2x squared minus 4 has a 2 that you could take out of both of those terms. So it is best to check for a GCF first, but you can catch it at the end if you are worried about missing it. It is important to take out the GCF because on this section, we are trying to factor as fully as possible. So that would cost you points on the test tomorrow. So we take out a GCF first, which gives us x cubed. That's 2x squared. My 2x minus 4. And then I have 4 terms, so I'm going to split it and factor by grouping. Or at least try to factor by grouping. So the 2 is going to continue to float on the outside, so make sure you bring that GCF down with every step of the work. We're going to take out an x squared from the first group, giving me x plus 2. Then we're going to take out a negative 2 from the next group. Why negative 2? Because we want those parenthetical terms to be the same so that I can take out a GCF of x plus 2 from both of those. So the 2 continues to float as the GCF. I take x plus 2 out of both of those terms as a GCF. And then x squared minus 2. And there's our factored form. Now on 19, unfortunately, there is no GCF. So if I were you looking at those giant numbers, I'd say, gosh, I sure hope one of those is a perfect cube. And what we see, since 27 is in our cubes column, that is a perfect cube, and so is 512. So 8 cubed gives me 512, and 3 cubed gives me 27. And I'll have this up during the test tomorrow so you can more easily identify those cubes. So 27 is a perfect cube. X cubed is a perfect cube. 512 is a perfect cube, and y cubed is a perfect cube. So we identify this as difference of cubes. So then I want to state the base that gives me that cubed. What cubed gives me 27? 3. What cubed gives me x cubed? X. So I write it as the base cubed, then minus what cubed gives me 512? The 8. And then y cubed gives me the y cubed. And I write it with those bases first because all of the pieces of that weird little sum and difference of cube formula are based off of those 2 items. So little parenthesis, big parenthesis. SOAP is the acronym we use for same as the sign between the cubes. Opposite of what we just wrote. Always positive, always positive. Our first step is to just straight up drop the bases. So 3x in the first slot, 8y in the next slot. In the first slot of your next parenthesis, you square the first base. Now, when I square 3x, we square both the 3 and the x, giving us 9x squared. The 9 is something that's normally missed. Same within the last slot, we square the 8 and the y, so 64y squared. Then for our middle term, we multiply the 2 bases together, so 24xy. Now, if you're looking at that second parenthesis going, oh my gosh, I sure hope we can't factor that. Folks, as a rule, if you have already tried taking out a GCF, once you try factoring something as sum or difference of cubes, you will not be able to factor it further. So that is our factored form. Looking at number 20, we start with a GCF. What can we take out of both of those? X squared. Can we factor it further? We can, because x squared is a perfect square and 4 is a perfect square. So again, folks, on the test, we want to factor it as much as possible. On that homework quiz we took, what you saw is that it didn't matter if I factored those difference of squares, because I could just do square root. But as far as breaking it down into factors, that is important for this section. Whoops, that's x squared. So that is our full factored form for that one. Then for 21.
Thank you.
So there's no GCF to take out on this one. Our powers go 4 to constant. So this is a fake quadratic. And we're going to do the x method. So x squared. 2 and 6. X squared times 6 is 6x squared. X squared times 2 is 2x squared. I need them both to be negative to get that sum of -8. So both of those are negative. So going straight across, x squared minus 2 and x squared minus 6. Can I factor those any further? Nope. Because 2 and 6 are not perfect squares, we cannot factor it as difference of squares or anything else. Folks, on the back page, I'm just going to straight up tell you that I want you to factor the first 4 problems. So the first 4 problems can be solved by factoring. The bottom 4 problems, you'll have to use your calculator and or P over Q values to solve. The 27 through 30, you should be able to purely factor. I think I'm going to do it this way on the test as well, tell you which ones can definitely be factored. If you get stuck, of course you can use P over Q values, but I don't want you to simply write the exact answers directly from your calculator on those ones. You can find one and then depress it. Does that make sense? What I'm looking for there. Use the rest of the time to work.